Okay. Welcome to the session, How to Tame a Dinosaur in 7 Steps, a subtitle using Eclipse for mainframe development. So, as usual, just a few words on me. My name is Thomas Zierer. I'm technical architect for the BioNLB, Bayerische Landesbank in Munich, and which I work for since October 1992, which pretty much makes me a dinosaur also. And because I started there as a mainframe developer using PL1 and COBOL, it's my passion to link the mainframe with a distributed world, and in this case, with Eclipse. So mainframe, first some words, what is it? For the next 30 minutes, it is heavy IBM Big Iron, it is Z-series architecture, it is System Z9, Z10, Z Enterprise, operating systems, MVS, OS390, ZOS, batch processing with JCL, job control language, but don't panic, we will not use punch cards in this, and programming languages, PL1 and COBOL. COBOL. Why? Why should we bother with COBOL? I mean, COBOL was developed in 1950s by famous Grace Hopper, Grandma COBOL. So this language is probably older than everyone in this room. So why should we bother with this? So, why do we still do it? It is, in 1999, people were surprised to learn that there were still systems which computed a year with only 2 digits. And the situation today is not too different from what it was 15 years ago. So insurances, financial institutes, like the one I'm working for, they still rely on systems which were developed in the 80s or even 70s. And these are not systems which perform exotic tasks. So oftenly they form the backbone of a bank's business model. And the funny thing is that we are all using these systems, although we will never get a glimpse on the real COBOL code. But just imagine if whenever we buy something on Amazon or eBay or whatever, when it comes to payment, I guarantee you, in 90%, it will be COBOL code that shifts the money from one account to the other. And nice statistics, although it is from IBM, they say about 55% of all worldwide business applications in one way or the other involve COBOL code. Okay, IBM is not neutral, that's clear. But in this case, I really tend to believe them. All right, before we start, a little demo. I would have loved to do the demos online, but there are too many difficulties. So instead, I recorded some movies, but these movies were live recorded, so I think that almost counts as live. So for the first one, let's do a small case study. Let's pretend we are a COBOL developer, and our manager comes to us and says, hey, we got some new regulations by the authorities. We have to adjust some lines of COBOL code in our accounting system. And let's further pretend we are a traditionalist. So we despise all these nice and fancy point and shoot and clicky clicky tools. We love our TSO ISPF editor just as every Unix enthusiast loves VI. So how would we do that now? All right, so we will open up our terminal emulation software, 3270, log on and switch to the development environment. Then we would navigate to our source code libraries. And here's a small just a small Hello World COBOL program. And let's pretend we do a mistake. We misspell a variable name. We save it. And then we switch to our job control library, where we got a pre-configured compile job. We run this job by entering submit in the command line. And we instantly get a return code 12, which means unsuccessful compilation. All right, we would now switch to the spool searcher facility, where we select the compile listing, which is the last one, we know that. We scroll down to the end, and in the end we receive a line, print_rec was not defined as a data name, statement was discarded. All right, so we would now switch back to a source code, try to remember the line number, correct the error, rerun the compile job, probably receive different errors, and repeat, until in the end we got a successful compilation. So, I think we should do better than that. All right, how to do that with Eclipse? So we open up the product, and as usual we have to authenticate. And on the left we have again our libraries. We filter the ones we want to see. And here again we have our source code, again with a small variable typo. So this is exactly the same source code as we saw before. All right. But instead of now switching to the JCL library, submitting a job, we do the following. So right mouse button, and we use I could call syntax check, and something happens in the background. And now we got a nice problem view with the correct error message. We have a marker in the editor displaying the correct error message. And now we can correct the error, all the errors we have received, save it, rerun the syntax check, and okay. So now we have a clean COBOL source code. So how to achieve this? How to tame this T-Rex, this dinosaur, in 7 steps. So here are the 7 steps. Search, find, catch, play, train, teach, tricks, and parade. Let's begin. Search is indeed the hardest part, because ZOS systems use a, well, let's call it unique file system. So they have data type, they have file system types like VSAM, physically sequential, partitioned, generation data groups. None of this exists in the distributed world. So this file system is absolutely incomparable to anything you have on Linux, Unix, or Windows. But we have to access this file system because this is where the source code is stored, traditionally. So the first approach, obviously, would be Target Management Plugin, aka Remote Systems Explorer. And although the RSE plugin supports ZOS as a target OS, it only offers access to the integrated Unix System Services file system, or OpenMVS, not the native file system, which we have to access. So this approach doesn't lead too far. Interesting, this is where IBM, Big Blue, comes back into play. So they have a family of products, so-called Explorers. These are Eclipse-based standalone clients to access several IBM mainframe products like CICS, IMS, Fault Analyzer, File Manager, and ZOS itself. So usually these clients, you can download them for free. Usually these clients come as a bundled Eclipse application. But there's also an update site for is, I've written down it here. So here's how it looks like, and we use one in the middle. I'm sorry if it's very small, but this is the IBM Explorer for z/OS. And with this, the next step, catch, is pretty obvious. All we have to do is include this update site URL in our product or in our Taco build. So that's all. So this step is pretty straightforward. Okay, so how does the actual Explorer look like? Okay. As usual, we have to identify. And let's just stop here. So on the left-hand side, we see again our file system, and I filtered out only my personal data sets, so not see all the rest. Here are the members. Here down is our SDSF system with job output. Here we have our different z/OS systems in case we have several ones for production, integration, and test. And usually we can double-click a member and get access to the source code. All right. Back to the presentation. Okay, so that's with playing. Now let's train the dinosaur. As you have mentioned, the default editor is a Notepad lookalike. So it's just a simple implementation of the abstract text editor. But building a custom editor is very, very easy. So Tom Schindel talked about that yesterday, so he would have got all the details. Basically, you just have to implement a partition scanner, a token, and an I-rule, and you get a really nice syntax highlighting. And all you have to do is include this new editor as a fragment into the original z/OS Datasets Explorer view. So that's pretty easy. But syntax highlighting, well, it's nice, but it's not what we are used from Eclipse. So we want a problem view. We want to have automated refactoring. We have code completion and so on. But so there we will reach limits. So for a automated code completion, we would need a language server which parses the code instantly. But the limitation is all the tooling usually is completely mainframe based. So the compilers are mainframe based, source code is mainframe based, everything. So there are distributed compilers for Windows or Unix, but first of all, they are expensive. And the second one, they are not 100% compatible. Plus, the compile listing is not meant to be analyzed by software. It's meant to be read by humans. So to analyze it would be very, very difficult. But all compilers support an option that let the compiler at least generate some of its information in XML format. So I've written down the option for COBOL, which reads like exit, add exit, elax mgux. Don't ask me where this comes from. So on PL1, I think it's called XN for XML, and there are similar options for C, C++, even assembler. Fortran, I'm not sure. And with this option, a variable typer, as we have had in the first demo, appears like this. So we have a message number, a message line, message text. which is obviously everything we need to populate the problem view. And with knowledge, populating the problem view is no rocket science. It's absolutely straightforward. First, you allocate a temporary data set on the mainframe, which suits for XML data. You generate a simple string containing a compiled script in JCL for compiling a specific source code. Then you transfer it to the mainframe and execute it. And when it's finished, you download the contents of this temporary data set, XML format, parse it, and for every compiler message you find in it, you simply place a marker into the problems view, an annotation into the editor, and whatever you like. And of course, in the end, delete the temporary data set. And the comfortable thing about it is there's a class provided, ZOS connectable, which is a singleton, which does all the magic stuff. So with this, you can submit jobs, write data sets, download its contents, allocate and delete data sets, whatever you like. Last step, parade. So now, we got a nice editor, we got some mechanisms which allows us to find and solve compilation problems quickly, but that's not enough. So for an IDE, we will also like to test our program, and that means to debug it. And for this demo, I prepared a PL1 program because I'm much better PL1 programmer than I am with COBOL. And I decided not to show how to prepare it. First of all, this goes very, very deep into ZOS language environment stuff involving real sophisticated assembler code. So if you're interested in this, please approach me. I will explain to you in detail. But I think for most of you, this would not be very interesting. And secondly, this involves very Bartleby specific stuff. So I didn't think that was of too much interest. But as soon as we've prepared this program, the beautiful thing is we don't have to run the program from Eclipse. We can also run the program directly from TSO-ISPF and only debug it with Eclipse. Final step. So here's again our libraries, and here's a simple run job. I run it, and instantly Eclipse pops up in the debug view. It stops in the first source code line, and then I can step-by-step debug the program. And okay, I let it run to a specific location because this is a call to an external subroutine, dvasmt. And the funny thing is, dvasmt is written in assembler. So this is why I have to issue some magic commands here down with the command line to explicitly load the debug data for it. And once I've done it and step into, we're right in the assembler code. So store branch and load register, store load address, load branch register 14, which lets us return to the calling routine. And here we are again in the PL1 code. So this is my favorite thing here. So debugging, step-by-step debugging of really ancient assembler code, even manipulating the base registers. This is really my favorite thing. So, quite good in time, I think. Okay. So, all right. So that's all from me. Thanks very much for your attention. And as we're pretty good in time, do you have any questions? Yeah.
One thing, it seems like you have to train the IBM Explorer afterwards. I expected there's like a product from IBM which has the syntax highlighting and so on.
No, there are commercial products from IBM, of course. There's a Rational Developer for Z, which does all this stuff and much more, but it is also much more expensive.
So it's a lightweight approach.
It's a very lightweight approach, yeah. So, and it's only BinLB code, and plus some plugins from IBM, which you may download for free. So okay, thanks again very much.